Very good morning, students. Unit 1 Basic Concepts of Chemistry and Chemical Calculations. In this session, I am going to teach Avogadro number, molar mass and molar volume. Molar volume. Okay. So, first one is Avogadro number. Avogadro number. The total number of entities present. The total number of entities present in 1 mole of any substance. 1 mole of any substance is equal to 6.022 into 10 power 23. Right? So, Avogadro number, the total number of entities. The entities means atoms or molecules or ions. The total number of entities present in 1 mole of any substance. Already you know that mole concept. So, 1 mole of any substance is equal to 6.022 into 10 power 23. This number is called Avogadro number, which is named after the Italian physicist Avogadro. He is known for the Avogadro hypothesis. Right? So, Avogadro hypothesis. Avogadro's hypothesis. So, define Avogadro hypothesis or Avogadro law. The equal volume of all gases. The equal volume of all gases. The equal volume of all gases. The equal volume of all gases under the same condition. The equal volume of all gases under the same conditions in temperature and pressure. The equal volume of all gases under the same condition in temperature and pressure contain the equal number of molecules. Equal number of molecules. The Avogadro hypothesis or Avogadro law. The equal volume of all gases. The equal volume of all gases. The equal volume of all gases. Right? So, carbon dioxide, ammonia, hydrogen and nitrogen. The equal volume of all gases. For example, 1 liter of carbon dioxide, 1 liter ammonia and 1 liter nitrogen and 1 liter hydrogen molecules. The equal volume of all gases under the same condition in temperature and pressure. So temperature and pressure is constant in all the vessels. Right? So contain under the same condition in temperature and pressure, they contain equal number of molecules. Equal number of molecules. So for example, carbon dioxide, atomic mass of molecular mass of carbon dioxide, carbon 12, each oxygen 16, 32, so 44. So 44 gram of carbon dioxide. Ammonia, nitrogen 14, hydrogen 3, so 17 gram of ammonia. The molecular mass of nitrogen, okay, so 1 nitrogen 14 into 2, 28 gram of nitrogen. Okay, so 2 gram of hydrogen molecules. 2 gram of hydrogen molecules. The equal volume of all gases under the same condition in temperature and pressures contain equal number of molecules. Equal number of molecules. The 44 gram carbon dioxide. The molecular mass of carbon dioxide 44 gram. The 44 gram of carbon dioxide contain 6.022 into 10 power 23 carbon dioxide molecules. The 70 gram of ammonia contain 6.022 into 10 power 23 ammonia molecules. 28 gram of nitrogen contain 6.022 into 10 power 23 nitrogen molecules. Right? So 2 gram of hydrogen molecules contain 6.022 into 10 power 23 hydrogen molecules. Okay, so all the gases contain same number of molecules. Avogadro number of molecules. So the equal volume of all gases, under the same condition in temperature and pressures contain equal number of molecules. Equal number of molecules. Already you know that how to calculate number of molecules. How to calculate number of molecules? The number of molecules is equal to molecular mass divided by mass of single molecule. Mass of single molecules. Mass of single molecules. Okay, so molecular mass of carbon dioxide 44 gram. The mass of single molecules. Mass of single molecules. Single molecules is equal to molecular mass by Avogadro number 6.022 into 10 power 23. Are you right? So 44 divided by Avogadro number is equal to mass of single molecules. So number of molecules is equal to molecular mass 44 gram divided by mass of single molecules value is equal to Avogadro number of molecules. Avogadro number of molecules. So all the gases having Avogadro number of molecules is Avogadro hypothesis. Do you understand, students? The equal volume of all gases, carbon dioxide, ammonia, nitrogen, hydrogen, எல்லாமே equal volume ல இருக்கும்போது, so அதனுடைய temperature and pressure constant ஆ இருக்கும்போது, அதுல இருக்கக்கூடிய molecules வந்து same ஆ இருக்கும். Number of molecules வந்து same ஆ இருக்கும் அப்படின்னு சொல்றாங்க, right? So the example of the reaction. In the chemical reactions, the atoms or molecules react in a specific ratio. In a chemical reaction, the atoms or molecules react in a specific ratio. So example 1, carbon reacts with oxygen to give carbon dioxide. And second example, example 2, methane reacts with the oxygen. Methane reacts with oxygen to give carbon dioxide and water. Carbon dioxide and water. Okay, so balance the reaction. Carbon 1, hydrogen 4. So 4. Oxygen 2 plus 2, 4 oxygen. So 2. Okay, so in this reaction based on the ratio of molecules. Okay, in the first reaction, the one carbon atom reacts with one oxygen molecules. One oxygen molecule. Right? So one carbon atom reacts with one molecule oxygen to give one molecule carbon dioxide. One molecule carbon dioxide. In second reaction, the one molecule methane reacts with two molecules of oxygen, or one molecule methane burns with two molecules of oxygen to give one molecule of carbon dioxide and two molecules of water. Two molecules of water. Are you right? So all the chemical reaction based on the number of ratio of the molecules. Ratio of the molecules. So practically difficult to count the number of molecules. Difficult to count the number of molecules. The scientists introduced the mole concept. Mole concept is very simple measurement. Okay, the 1 mole of the 1 mole of carbon reacts with 1 mole of oxygen to give 1 mole of carbon dioxide. To give 1 mole of carbon dioxide. In second reaction, the 1 mole of methane, 1 mole of methane reacts with 2 mole of oxygen, bonds with 2 moles of oxygen. 2 moles of oxygen to give 1 mole carbon dioxide and 2 moles of water. 2 moles of water. Are you right? But the scientists used the only involved in atom reactions. The atom involving reaction, the scientists used 1 gram atom instead of mole. Instead of moles. Are you right? Okay? Are you understand, students? Avogadro number 6.022 into 10 power 23. Right? The equal volume of all the gases contain same number of molecules. Same number of molecules. Right? Okay, students. The next one is molar mass. Molar mass. Molar mass. Already you know that atomic mass atomic masses, molecular masses. Atomic masses and molecular masses. So mass of one atom and mass of one molecules. Okay, so cannot measure directly in atomic mass. So to measure relative atomic mass or average atomic mass. The relative atomic mass is equal to the average mass of the atom divided by unified atomic mass. The molecular mass is defined as the ratio of the mass of one molecules to the unified atomic mass. Are you right? Okay. So the next one is molar mass. Define molar mass. The molar mass defined as the mass of 1 mole of the substance. The mass of 1 mole of a substance is called molar mass. The mass of 1 mole of substance. Okay, so the mass of 1 mole of hydrogen, mass of 1 mole of glucose. Are you right? So the mass of 1 mole of a substance. The mass of the compound, the mass of a compound is equal to the sum of the relative atomic masses, the sum of the relative atomic mass of its constituent atom. It expressed the gram molarness. Gram molarness. Molar mass, atomic mass, molecular mass, எல்லாம் ஒரே கான்செப்ட். இத AMU ல சொல்றோம், atomic mass ஐயும் molecular mass ஐயும் அதே வேல்யூஸ gram molar mass ல சொன்னோம்னா molar mass. For example, the relative atomic mass of one hydrogen is equal to 1.008 unified atomic mass. But the molar mass of hydrogen is equal to 1.008 gram mole inverse. Right? The next one example, the molecular mass of glucose. Molecular mass of glucose is equal to 180 U. Right? The molar mass of glucose is equal to 180 gram mole inverse. Okay, so molar mass expressed in gram mole inverse. Atomic mass and molecular mass expressed in U, unified atomic mass. Are you right? Okay, students. The next one is molar volume. The next one is molar volume. Molar volume. Okay, so the volume occupied. Okay, so the volume occupied by that volume. Okay, so the volume occupied by 1 mole of any substance in a gaseous state. In the gaseous state at a given temperature and pressure is called molar volume. Okay, the volume occupied by 1 mole of any substance. The volume occupied by 1 mole of any substance in a gaseous state. In a gaseous state. Okay, so at a given temperature and pressure. Okay, so molar volume, the volume occupied by 1 mole of any substance. 1 mole of any substance in a gaseous state. In a gaseous state at a given temperature and pressure is called molar volume. You right? So, 1 mole gaseous substance, 1 mole gaseous substance given temperature and pressure, 1 mole gaseous substance given temperature and pressure எவ்வளவு வால்யூம் ஆக்குபை பண்ணுமோ அந்த வால்யூம் தான் molar volume. You understand, students? So, the 1 mole of any substance in gaseous state. Gaseous state la irukக்கூடிய 1 mole of this substance given temperature and pressure la எவ்வளவு வால்யூம் ஆக்குபை பண்ணுமோ அதுதான் molar volume அப்படி சொல்றோம். இப்போ நம்ம different conditionsல okay, different temperature and pressure la molar volume 1 mole substance, gaseous substance உடைய molar volume calculate பண்ண போறோம். Okay, the first STP condition. Next STP condition le old version. So இது new version STP, இது old version. அடுத்து SATP இது பாப்போம். STP அப்படினா standard temperature and pressure. STP standard temperature and pressure. So ಇದು same standard temperature and pressure. Standard temperature and pressure. But SATP means standard. The standard ambient. The standard ambient temperature and pressure. Temperature and pressure. Ambient means surrounding, சுற்றுப்புறம். Okay, the standard ambient temperature and pressure. Are you right? So already you know that the ideal gas equations. Ideal gas equation PV is equal to NRT. The ideal gas equation PV is equal to NRT. It's the ideal gas equation. PV is equal to NRT. So calculate the volume. So V is equal to NRT by P. NRT by P. Okay, so all the substance contain 1 mole. So N is equal to 1 mole. 1 mole. Alright? So STP condition. So V is equal to NRT by P. P is equal to NRT by P. In all the condition, N is equal to 1. N is equal to 1. Right? So R is equal to gas constant or 0.0821 liter mole inverse ATM and Kelvin inverse. Okay, so R value is same in all conditions. Okay, next temperature. The STP condition 0 degree Celsius. STP condition 0 degree Celsius. 0 degree Celsius. So 273 Kelvin. Right? So standard temperature and pressure. The standard condition temperature is 0 degree Celsius. Okay, so T value 0 degree Celsius. 273 Kelvin. 273 Kelvin. So standard T is equal to 273 Kelvin. Right? So but in ambient temperature, so surrounding temperature is 25 degree Celsius. 25 degree Celsius. Are you right? So 25 degree Celsius, 0 degree Celsius is equal to 273 Kelvin. So 25 degree Celsius, 273, 25 is equal to 298 Kelvin. So T value, T value, the temperature T is equal to, in SATP condition, temperature T is equal to 298 Kelvin. Okay, so in the order வந்து bookல மாறி இருக்கும். So கொஞ்சம் change பண்ணிக்கோங்க. Ambient temperature தான் 298 Kelvin. 298 Kelvin. SATP ஓட temperature தான் 298 Kelvin. Okay, so next pressure. Okay, pressure in new version STP, standard pressure 1 bar. Okay, so pressure P is equal to 1 bar. 1 bar. 1 bar is equal to 100 kilopascal. 100 kilopascal. That is equal to 0.987 atm. 1 bar is equal to 0.987 atm. Okay, easy enough. 789. 0.987 atm. Okay, so in STP old version pressure is 1 atm and SATP are also pressure is equal to 1 atm. Are you right? So the volume calculation, the molar volume in STP condition V is equal to N 1 mole 1 mole into R 0.0821 liter mole inverse atm Kelvin inverse T 273 Kelvin divided by P 0.987 atm. Okay, so atm cancel. atm cancel, right? So mole inverse cancel. Kelvin inverse cancel. Remaining liter. Okay, so that is equal to 0.0821 into 273 divided by 0.987. Okay, so 987 liter. Okay, simplify the values. We'll get 22.71 liter. 22.71 liter. Are you right? So in SATP condition, V is equal to 22.71 liter. 22.71 liter. Are you right? Okay. The next STP old version. Okay. So N equal to 1 mole. So no change. R value are also does not change. 0.0821 liter mole inverse. atm Kelvin inverse. Temperature are also not change. 273. But pressure value 1 atm. Pressure value 1 atm. Right? atm cancel. Kelvin inverse Kelvin cancel. Mole inverse mole cancel. So remaining 0.0821 into 273. Okay, so that is equal to 22.4. Okay, simplify the values or multiply the both values to get 22.4. 22.4. Okay, 22.4. So therefore the B value, right? So the V value, V is equal to volume, V is equal to 22.4 liter in old version STP condition, right? Okay, STP condition. So the last one, SATP condition. SATP condition. The V is equal to 1 mole. N value 1 mole into R 0.0821 liter mole inverse atm Kelvin inverse into T 298, right? So ambient temperature 298 Kelvin divided by P1 atm. So atm cancel, Kelvin inverse Kelvin cancel, mole inverse mole cancel, remaining liter, that is equal to 0.0821 into 298 liters. So therefore V is equal to 24.5 liter. 24.5. Right? The molar volume in STP condition, so 22.71 liter. 22.71 liter, and old version STP molar volume 22.4 liter. 22.4 liter, and SATP condition the molar volume V is equal to 24.5. 24.5 liters. Okay, are you understand, students? Right? Okay, students. Evaluate yourself. Third question A. Question number third A. Calculate the number of moles present in 9 gram of ethane. Calculate the number of moles present in 9 gram of ethane. Ethane, Std-XI ethane. Okay, so calculate the number of moles. Already you know that the number of moles. The number of moles. So given mass. So given mass by molecular mass. Given mass by molar mass. Given mass by molar mass. So molar mass of Std-XI. So 2 into C. 2 into 12, 24. Okay. So 6 into hydrogen. 6 into 1, 6. So 30 gram. Given mass of, molecular mass of or molar mass of ethane 30 gram. So that is equal to given mass 9 gram of ethane divided by molar mass 30 gram mole inverse. 30 gram mole inverse, molar mass, gram mole inverse. Okay, so that is equal to 0. So 90 by 30, 3 gram cancel, so mole. So calculate the number of moles present in 9 gram of ethane is equal to 0.3 mole. 0.3 mole. Okay. The next one is question number 3 B. Calculate the number of moles. Calculate the number of moles of oxygen gas that occupy a volume of 224 milliliter. So given volume is equal to 224 milliliter is equal to 0.224 liter. 0.224 liter. Okay. So at 273 Kelvin, T is equal to 273 Kelvin, and P pressure is equal to 3 atm. 3 atm. So calculate the number of molecules. Already you know that the number of moles. The number of moles is equal to number of molecule. Number of molecules divided by Avogadro number 6.023 into 10 power 23. So calculate the number of moles. therefore number of moles, number of molecules. Calculate the number of molecules. Okay, so number of molecules is equal to number of moles into Avogadro number 6.023 into 10 power 23. You right? So already you know that PV is equal to NRT. Okay, so PV is equal to NRT. Okay, so number of molecules is equal to number of moles into Avogadro number. To calculate the number of moles, so number of moles N. So therefore N is equal to PV by RT. PV by RT, that is equal to P 3 atm. Okay, so P 3 atm, 3 atm into V 0.224 liter. 0.224 liter. Okay, so divided by R 0.0821 liter mole inverse atm Kelvin inverse into 273 Kelvin. 273 Kelvin. Kelvin inverse cancel. atm cancel. Right? Liter cancel. Mole inverse is changed into mole. Are you right? So that is equal to 3 into 0.224. 3 into 0.224 into 0.0821 into 273 mole. 73 mole. Okay. So simplify the values. Will get 0.03 mole. 0.03 moles. So number of moles. The number of moles contain 224 milliliter at 273 Kelvin and 3 atm pressure of oxygen is equal to 0.03 moles. So therefore the number of molecules of oxygen gas, the number of molecules is equal to the number of moles 0.03 into Avogadro number 6.023 into 10 power 23. Number of molecules. Okay, so Avogadro number does not have any unit. So no unit in Avogadro number. Okay. Okay, 0.03 into 6.023 into 10 power 23. Okay, so 6.023 into 3. 3 into 3, 9. 3 into 2, 6. 300. 3 into 6, 18. Okay, so 18, right? How many digits? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that is equal to 0.18069 into 10 power 23, or that is equal to 1.8069 into 10 power 22 molecules of oxygen. Okay, so the number of molecules of oxygen 1.8069 into 10 power 22 molecules of oxygen. Okay, students. Thank you, students. We'll meet next class.